let's talk about Matplotib now. I mean,
Yeah.
when did you first when did you meet John Hunter? When did you
Yeah.
how did that sort of process start?
Sure. So I used Matplotlib on this music project. That's where I first became aware of it. I used it to sort of analyze what was going on in the data and trying to improve the models. Um, but it wasn't until I started working at the Space Telescope Science Institute, with where my boss was Perry Greenfield. My first assignment there was to work on Matplotlib. They said what we want to do is we have these things in Matplotlib that we need to improve for our own work. Could you please work on that? And while you're working on that, go ahead and triage some bugs and help people on the mailing list and do sort of the open source maintenance stuff. And at the time, and even a little bit now, Space Telescope has been very big on supporting the Python, NumPy, SciPy ecosystem. They did a lot of the early development of NumArray, which is a library that preceded NumPy. And so, yeah, it was a really good place at the time to support open source and be working on open source. And I met John Hunter just sort of over the phone. We would have phone meetings at that time, and I hadn't met him in person, but we would have meetings on the phone about, various technical things and what we should be doing. At that time, he was quite busy in another job, and so he was working on it less and less, and I think was appreciating other people coming in. And then I think I met him in person for the first time at SciPy, probably 2008, I would guess, which was one of them in Pasadena, California, at Caltech. And just a great guy. I mean, immediately. One of the things that he taught me about open source that I think is really important is there's very little reason to be protective of commit rights to your repository. I think a lot of projects or a lot of original authors, which he is of Matplotlib, are sort of very protective. Like, this is my project, and yes, I can have people contribute to it, but I want to have final say about what goes into it. And he had a very different attitude. He was like, if somebody comes and they are motivated enough to want commit rights, I'm going to give them commit rights. And he says, I've been doing this all along, and I've never regretted it. No one's ever made a mistake so serious that it couldn't be fixed. Sometimes maybe you have to go back and say, yeah, that was a bad idea. Let's revert it. But really, there's always a benefit, I think, of being as inclusive as possible, as early as possible on open source projects.
Right.
Yeah.
It's quite a nice story. So Matplotlib has sort of been relevant throughout the whole period. So were there any alternatives to Matplotlib when it started? And how has it been able to sort of be super relevant even now? I mean, it's probably it's one of the most commonly used Python libraries. So how? So you are the lead sort of developer, or you were the lead developer?
I no longer am. I don't have a lot of time for it.
Right. So, but you've seen it grow. So, what do you think were the primary reasons that sort of helped it grow along the way?
So, my memory is probably going to be a little vague way back then, but I do remember there were some alternative Python plotting libraries at the time. Many of them were designed for one particular GUI toolkit or one particular operating system. And I think Matplotlib was the first one that said, we're going to have a bunch of different backends. So the backends are basically how it communicates with different GUI frameworks and different operating systems. So, Matplotlib works with GTK and Qt and TK, and there's one specifically for Mac OS, and I think there at one time was one specifically for Windows. And what that meant is anybody could run it. It didn't matter what their application technology they were using was, Matplotlib would work with it. And I think that was a big part of its success and why it took off. I think those things are becoming less and less relevant now because as the web is sort of becoming the dominant platform and most people are using Jupyter notebooks to do their data science and stuff, like having a Qt backend is less important. It is still important in some use cases. But I think that was a big part of success first. And then also, it's included a lot of features over time. Like, again, I think with John's attitude, like, if you have a feature you want to add, let's just add it. Let's get this thing to include it. So it has these very sophisticated Sankey diagrams that are used in EE, and it has great violin charts, and it has all these different plot types, and they're all just there. I think that's a real strength. From a developer perspective, I know that that's sometimes tricky on us, particularly like the core maintainers when I was a core maintainer, because every change that you made to Matplotlib, there was so much code in there that the likelihood of breaking something was really, really high. And so one thing I've talked about for a number of years and haven't had the time to do, but I talk about this with Thomas Caswell, who is the current maintainer. I've had conversations about this. One thing we'd like to do at some point is re-architect it so it has a set of core functionality with a really clear API about how to use that core functionality that wouldn't change very often, and then have all these plot types kind of go out into separate projects and let other people maintain those, and they would just work against this stable API, and that way we as Matplotlib, I guess maybe I'm not part of the we anymore, but the Matplotlib developers don't have to maintain all of it all the time. It could be more distributed.
Right. So Matplotlib has been exclusive for Python. So at any point of time during the whole during the timeline, was it considered to sort of allow other people to build, or to build for other languages, to have Matplotlib for other languages, Node, JavaScript, Ruby, and things like that?
Yeah, well, I think it would be a great idea. I mean, one of the things that you see, not just in data science, but in software engineering in general, is these languages tend to create silos of technology. Do you know what I mean? Like, if you're a JavaScript programmer who uses Node, you're going to use the JavaScript HTTP library, even though maybe some other language has a better one. You're just going to use the one that's in that silo. And so definitely in the Python world, you have the silo of all the Python tools. And they're very good tools, but it's hard for us to collaborate with the R community that has good strengths in other areas, right? So it would be, I think, as part of this re-architecture, if you're going to take it one step further, you would have a core that is probably written in something like Rust or C that's very, very portable, and then wrap it for all these other languages. So you have Python bindings and Ruby bindings to it, and then et cetera, et cetera. And then it could be used by all these things. Obviously, this is a lot of work, and someone needs to do the work.
But probably focusing on one specific language would, since there's a lot to cover, and like you spoke of the problems, that it has to be quite inclusive, and then you have to maintain the code and things like that. So it's probably better if you can just focus on providing the best sort of software for one language, and that's probably not caring about the other languages.
That's true. Certainly from a time spent, value versus time spent, focusing on the one thing was the right choice, and probably still is the right choice. And interestingly too, Julia, when they started, didn't want to rebuild a new plotting library in Julia, so they actually include Matplotlib, and there's a very sophisticated set of bindings between Julia and Python, so that you can do your data science in Julia and then pass it to Matplotlib for your plotting, and it works amazingly well. So there are kind of I don't want to call it a hack, but there are sort of tricky ways to make that work too that have been successful.
So one of the most common ways is, using Parudite. Not the most common, it's coming out. So we'll talk about that later.
Sure.
But having been the lead developer at Matplotlib, what sort of advice would you give to people who are, groups of people who are coming together and making open source softwares, just starting out, probably trying to be as successful as Matplotlib, NumPy, things like that. So what sort of advice do you think would be helpful to people starting out?
Well, I think a lot of these tools like Matplotlib and NumPy are successful because their initial developers were scratching an itch and an interest that they had themselves. Matplotlib was made, as I understand it, by John Hunter for his neuroscience work that he was doing at the time. He couldn't find a tool to do the neuroscience work that worked well enough, so he started Matplotlib. And he had sort of a very strong personal motivation. And I think in open source, particularly if you're volunteering your time to do it, you really have to be committed to it, and you have to have a personal passion for what you're doing. So I think it's important to not set out to like, what could I do that would be super successful? Just set out and do what is important to you, and I think the success will come from that, if that makes sense.
Yeah, right.
Yeah.
So have a clear goal of what you want to build.
Yeah.
And be sort of motivated about it, something that drives you, and then
Yeah.
communicate with people. And
Yeah.
make sure that the thing. Everything falls into place. And
Yeah, because I think if it's something you're passionate about, you will do a very good job. And if it's something you're passionate about, there's a very good chance there's a lot of other people that'll be passionate about it too.
Right. Will come along and help you get there.
Exactly. Yeah, be confident that your excitement is real and shared.
Right.
Yeah.
And only then, sort of the people who are working with you, they'll be able to sort of get the excitement.